introduce to you the materials and equipment for our experiment. The mortar and the pestle, the evaporating dish, the goggles, Florence flask, graduated cylinder. Inside of it is the methanol, ethanol, we have the dropper, hydrochloride acid, water distilled, and at the back we have the funnel. And holding together the pieces is the test tube rock. Here we have the 4 pieces of paracetamol, 4 pieces of snow beer, the was, and the baby powder. Snow bear or candy. The candy is harder to grind, it has larger particle, the appearance has crystallized sticky type of result, and the candy is not well grinded to smaller portion. It has a smell of an aromatic, sweet, tasty candy. Methanol. Adding 5 drops of methanol in the snow bear candy, mixing together within 39 seconds. Mixing similar to ethanol, this colorless, mildly sweet smelling liquid will dissolve the candy with methanol and oils dissolving readily. The solution is clear and has a faint mint alcohol odor. Physical changes: rapid dissolution compared to water, no color change. Methanol is also changeable, so evaporation may be observed. Under microscope, the mixture has a cloudy appearance due to undissolved sugars with distinct crystalline shapes, less defined than in water. Ethanol. Adding 3 drops of ethanol in the snow bear candy, mixing together within 28 seconds. Mixing the colorless, slightly strong liquid will melt or wet the candy so the candy may dissolve faster, forming a clear but still mint-scented solution. Physical changes: the candy softens and dissolves. The solution remains mostly colorless. Ethanol's volatility may cause a slight cooling sensation as it evaporates. Under microscope, forming fine, slightly rounded edges, the solution is somewhat cloudy with visible solid particles and some well-formed citric acid crystals. Hydrochloric acid. Adding 3 drops of hydrochloric acid in the snow bear candy, mixing together within 25 seconds. Mixing the clear, strong liquid will immediately react with the candy. Bubbles may form as acids react at any residue carbonates. The candy dissolves quickly, forming a clear, acidic liquid with a strong minty acidic smell. Physical changes: the candy may change slightly. The solution remains clear but may have a faint yellow hue. Under microscope, no significant chemical reactions occur, so the solution is clear with no visible crystals. Distilled water. Adding 4 drops of distilled water in the snow bear candy, mixing together within 31 seconds. Mixing the clear, odorless water with the hard, white translucent candy balls. Upon stirring, the candy will gradually dissolve, forming a cloudy, slightly viscous liquid with a minty scent. Physical changes: the solid candy structure breaks down, no dramatic color occurs. Here, the solution may take on a very pale yellow tint from trace ingredients. Under microscope, the overall mixture shows dispersed fine particles and some crystalline structures against a clear background.
The was crystal deodorant. It has slight appearance of rough, smooth, and shiny glowing diamonds that can be seen through the magnifying glass. The smell of the substance has no smell at all. Methanol. Adding 2 drops of methanol in the tawas, mixing together within 29 seconds. Mixing. Tawas has very low solubility and alcohols. Most solid crystal remain undissolved at the bottom. The liquid stays clear and colorless. Mixing may disperse fine particles temporarily, creating a cloudy suspension that settles quickly. Physical changes. No significant chemical reaction occurs between tawas and these alcohols under normal conditions. No gas, heat, or color change is observed. Under microscope, undissolved particles appear as small, irregular fragments or fine, scattered crystal without a fixed geometric shape. Ethanol in the tawas mixing together within 23 seconds. Mixing. When ethanol is added to solid tawas, the crystal do not dissolve significantly since tawas has low solubility in ethanol. Physical changes. Under normal conditions, tawas and ethanol do not undergo a significant chemical reaction. Under microscope, shows fine, unevenly distributed particles or tiny distorted crystal with blurred edges. Hydrochloric acid. Adding 2 drops of hydrochloric acid in the tawas mixing together within 18 seconds. Mixing. When dilute HCl is added to a tawas solution, the mixture remains clear and colorless initially. If concentrated HCl is used, slight warning may occur due to heat of dilution. Physical changes. At low HCl concentration, no reaction takes place. Under microscope, no visible crystal. In concentrated acid, if evaporated, the resulting solid has to disrupted lattice structure with pitted irregular surfaces due to acid ions affecting crystal formation. Distilled water. Adding 3 drops of distilled water in the tawas, mixing together within 31 seconds. Mixing. Tawas dissolve gradually when added to distilled water, forming a clear, colorless solution as particles disperse. Physical changes. No chemical reaction, only physical dissolution. The solution remains stable under normal conditions. Under microscope, it forms colorless, transparent, octahedral or cubic crystal with sharp edges and irregular lattice structures, and the surfaces are smooth.
Paracetamol. Paracetamol can be easily grinded to smaller and greater portions of small particles. The color outcome of the substance has portions of colorless, odorless. It has no distinct or noticeable smell under normal conditions. Methanol. Adding 2 drops of methanol in the paracetamol mixing together within 34 seconds. Mixing paracetamol is soluble in methanol. When added to methanol, the white crystalline powder gradually dissolves, forming a clear, colorless liquid with an alcohol-like odor. In physical changes, under normal conditions, there is no significant reaction. Under microscope, with sharp angles and smooth surfaces, the crystals are generally smaller than those from water. Ethanol. Adding 2 drops of ethanol in the paracetamol mixing together within 29 seconds. In mixing, paracetamol is easily soluble in ethanol. The white powder dissolves upon mixing, resulting in a clear, colorless solution. In physical changes, similar to methanol, no major reaction takes place under ordinary circumstances. Under microscopes, crystallized crystals are colorless, elongated prisms, or needle-like structures that may aggregate into clusters. Hydrochloric acid. Adding 2 drops of hydrochloric acid in the paracetamol, mixing together within 51 seconds. Mixing. Paracetamol is slightly soluble in dilute hydrochloric acid. When mixed, some of the powder dissolves, creating a pale yellow or light brownish solution. In physical changes, concentrated HCl can facilitate the hydrolysis of paracetamol's amide group, producing p-aminophenol and acetic acid. Under microscope, no crystals are visible. If evaporated, the resulting solid may show distorted or aggregated crystalline structures with painted surfaces. Distilled water. Adding 4 drops of distilled water in the paracetamol, mixing together within 46 seconds. In mixing, when added to water, most of the powder remains undissolved, forming a suspension. In physical changes, paracetamol undergoes slow hydrolysis in water. Under microscope, forms colorless, transparent columnar crystals with well-defined edges and flat surfaces belonging to the monoclinic polymer.
Baby powder without any liquid. The appearance of this substance is already in a state of a powdered substance. Unlike the other 3 substances is needed to be ground to smaller portion, the smell is addictive that has a sweeter aroma. Baby powder under methanol. Adding 2 drops of methanol in the baby powder, mixing together within 29 seconds. Methanol is a clear, colorless liquid. When added to baby powder, the powder initially absorbs it in forming a damp, clumpy paste or slurry. Physical change. No significant chemical reaction. Normal condition methanol acts as a solvent or wetting agent only. Under the microscope, particles maintain their granular shape but may appear slightly swollen or have blurred edges due to solvent interaction. With ethanol, adding 3 drops of ethanol in the baby powder, mixing together within 27 seconds. Ethanol is also clear and colorless, similar to the methanol. It wets the powder, forming a clumpy. The mixture stays white. Physical change. No chemical reaction takes place. Ethanol may evaporate more quickly than methanol, leaving the powder dry again over time. Under the microscope, no dissolution or significant structural change occur and particles are well separated in the low solution. While the hydrochloric acid, adding 3 drops of hydrochloric acid in a baby powder, mixing together within 25 seconds, dilute HCl is a clear, colorless liquid. When added to the mixture becomes a cloudy, acidic slurry with a concert-based powder. It forms a thin, clumpy mixture. Physical change, breaking down into smaller sugar molecules, which cause the mixture to thin and become less cloudy. While under the microscope, cornstarch undergoes acid hydrolysis over time, causing granules to swell, rupture, or form a cloudy amorphous mass with no distinct particle shapes. While in distilled water, adding 3 drops of distilled water in the baby powder, mixing together within 26 seconds, water wets the powder, forming a smooth white phase and no color change occurs. The physical change, no chemical reaction with pure talc or cornstarch. Under the microscope, cornstarch particles are insoluble, appearing as a regular oval or polygonal granules with a characteristic layered or striated surface texture.